Okay, Coroneos 100 integrals, number 57. All right, so for this question, we need to integrate x plus 1 over the square root, because that power half is actually just a square root of that quadratic. So it's kind of questions where we have a quadratic on a denominator, and we've got a linear function on the top. All right, so how would you do this one? The first reaction when I first see a question like this is I try to differentiate what's inside it. Right, that gives us 2x minus 3. So what I like to use is something called a reverse chain rule, and hopefully I can use it to solve this question here. But obviously there's a power half here that creates a bit of a problem. So I guess I would need to have 2x minus 3 to be replaced, to replace the numerator on the top there. All right, so that's the m's I have here. All right, and let's see if that gives us some hint after we use the algebra manipulation to change the numerator into 2x minus 3. So I'm just going to write down the derivative of what's inside this bracket is equal to 2x minus 3 here. So that gives us a hint. What we need to do is I need 2x minus 3, and I need to replace the numerator by 2x minus 3 as well. So we'll start the process. So first of all, let's put a 2 on the top. Just times everything by 2. And obviously I can't change the question, so I have to times by half outside. And we copy everything down for the denominator. So that gives you to the power of half dx. All right, so now continue the process. I need to minus 3 here, so what I do here is minus 3, but you can also plus 5. So minus 3 plus 5 gives you 2. So as you can see here, overall I changed the expression from x minus x plus 1 into this expression here with the half outside attached. But overall I haven't really changed the value of the question. The question still remained the same here. Alright, so now I can put a bracket like this, and we start to separate this into two fractions. So at least the first one I can use the reverse chain rule to answer the question. And we start to deal with what happened to the second part. Maybe for the second part, it's better for us to write on a square root. Okay. All right. Now, with the first one, it's really hard to see or use the reverse chain rule if it's in terms of fraction. So again, I would like to change the denominator into a power of negative half. So that way it's a bit easier. All right, for the second part here, whenever you see a square root on the denominator and inside it is a quadratic, the first reaction that you need to have is maybe it's this type of questions where we need to integrate 1 over the square root of x squared plus a squared, this kind of question. Which the answer for that one is just ln, brackets x plus the square root of x squared plus a squared. Okay, so that's the answer for that part. If we can change what's inside the square root to something that's very similar to this. Okay, so what we need to do is we need to completing the square for the first part here. So let's just start the process of completing the square. So that gives us x squared minus 3x plus 3 on 2 square minus 3 on 2 square plus 2 dx. All right, now I don't really like to integrate part by part, so I prefer just to do everything in one go. So I'm still going to write everything down and just copy everything down. Okay, now for the second fraction on the denominator, so finally it's changed into a nice quadratic. Okay, so that gives us x minus 3 on 2 square. Okay. We also need to do the calculation for this part here. That's minus 9 over 4 plus 4 over 4. So that should give us minus 5 over 4 here. Okay, I hope this is right. And I'll just double check. No, minus 9 over 4 plus 8 on 4. Yes, I made a mistake. So that's minus 1/4. Okay, it's dx. All right, so now if you compare this formula with the formula here, it looks very, very similar. Apart from here is just, that's a plus, here's a minus. Now that's not a big problem here. So we can actually start with the answer. We can do the questions now. All right, so let's move on. So that gives you half. All right, Now, with this one, what we need to do is we need to think about how do we, integrate this. The derivative of this term is equal to in the front, so that becomes a reverse chain rule. Okay, so I'm just going to copy everything down for the second term, plus this power by 1, so that gives you power of a half. Find the reciprocal of that power, which is just placed in front of it. So you get power of, so you've got 2 in the front. Okay, all right, for the next one here, we just need to use the formula that provided to us here, and that should be quite easy to work out the answer. So that gives us 5, should be just a 5, and ln and bracket x minus 3 onto like a square. Okay, so we just have to still have a square like this, and then we need to plus the square root of everything here, which is inside. So if you think about what's inside there, it's just the original expression, which is x squared minus 3x plus 2. And square bracket plus c here. Okay, so that should give us the answer. Yeah, okay. All right. So now let's just move on to simplify it, okay? So I guess I can just times the half to what's inside. So that gives you x squared minus 3x plus 2 to the power of a half plus 5 onto ln. Shall we simplify what's this one? I think we can, but there is not really a point of doing that, okay? So we can just leave the answer like this. So that gives us x minus 3 on 2 square plus square root of x squared minus 3x plus 2. Okay, all right, so that's the answer for this question. All right. And yeah, it's pretty interesting for this question here because of we need to use that part of the formula to do the question. Now, with the formula, that was a plus here, and that was that was a minus there. What is the difference? Well, there is not much difference because the other formula, if you want to think about this as minus, then the only thing that's changed is what's inside the square root. So that's still a plus here. There's a proof for that formula. But in the previous HSC course, that was in the standard integrals, but now it's not. So I guess they're not going to give you a question like this unless they ask you to prove that formula first. Okay. All right, so it's a pretty difficult question where you need to use an algebra manipulation to change the numerator. So you end up with a partial fraction, a reverse chain rule here, and also using the standard integrals for the second part. Okay, thanks for watching.